Now, some of those sedimentary structures that we might see in our sedimentary rocks are going to be deposited by moving water. So we're going to call this current deposition, right? Whether the water's moving fast, moving back and forth, right? It can leave telltale signs in the rock. So usually we see this, these different types of current depositions. It's going to be explained by the flow, right, of the water, whether it's moving fast or slow or back and forth, and the grain size, right, of the material that it's affecting. So the first type of sedimentary structure that we can see are called ripple marks. I guarantee you've seen ripple marks before. If you've ever taken a look at a pond or a lake, at the bottom of it you might notice, right, there are these little undulations right at the bottom. Those are ripples. And we have two kinds of ripples. We can have asymmetric and symmetric. So asymmetric, right, ripple, as you see down here in this picture. So here's the crest. Asymmetric means it's not symmetrical from one side to the other. When I see an asymmetric ripple mark, that's telling me that the water is moving in one direction. So what's happening is as the water is moving, it's picking up and moving grains, and it's piling up the grains. So so let's see. So let's draw. Here we go. Here's the water. Right, say the water's moving this way. That sediment is just going to pile up. Right, it's just going to make a big pile, and the water is going to continuously push on this pile, right, and flatten it out. So what I see is where the long slopey side is. That's pointing to the direction of current. Okay. So if we take a look at this picture down here, right here we've got the long slopey side, then we've got the steep side down here. So that long slopey side is telling me that that water was moving in that direction, but it was moving in one direction. Now, on the other hand, if I look at symmetrical ripple marks, this is telling me I have waves, right? I've got water moving back and forth and back and forth. Because what's happening is the water, right, if I've got my little sediment pile here, the water's pushing the pile this way, then it's pushing it back this way, then it's pushing it this way, and then back. So it's going to keep that crest right in the middle. We tend to find this at our beaches, right? As that should make sense. As the tide, there's the waves come in and go out, go in and go out. It makes it nice and symmetrical. Now we can also see dunes. Dunes are nothing more than really large ripple marks. But here the medium obviously isn't water, but it's wind, right? So if you take a look at these big dunes here on the picture on the left, you can still see the same structure where you've got this long slopey side and then a short side, right? Long slopey side and then a short side. Long slopey side and a short side. So they're still showing that same asymmetrical pattern, which is telling us the direction of the wind movement. Now, this is a great picture. I've actually been here. This is White Sands National Monument in New Mexico. And here we have selenite, which is a form of gypsum. That's the mineral here, and it's forming these big dunes. And what's really cool is here you can see the dune. This is the long slopey side and then the short side. So we know the wind, as you can see, is moving that direction. But what's really great about this picture is I want you to focus on this tree here. This tree has been drowned by the dune. Dunes slowly move across the dune field, right? They don't stay in one spot. They're moving grain by grain as the wind pushes it. And this is a great example. So this tree was once exposed, and now the dune is moving across it. Eventually it'll be exposed again, right, as the whole dune moves. To me, it's kind of mind-blowing a little bit. Now, when I look inside of a ripple mark, we can see these things called crossbeds. So a lot of the times, the ripple itself may not get preserved, but what's inside of it will, and this is called a crossbed. So let's talk about how crossbeds develop. So let's again put ourselves down here on the water bottom. Okay, so say the current's going this way. So remember, our grains are going to stack up, right, over time, and they make that nice little, right, asymmetrical ripple mark. Now, what will happen is this ripple can only get so high, right? It can't get forever high. Excuse me. I'm going to pull it down. So what will happen is the water is going to pick up this little grain right here. And this little grain is going to come up here and commit grain suicide and fall down right here. And then the next grain is going to get picked up and it's going to do the same thing. So what we're going to end up seeing are these stacks of grains that form on this very steep side. All right, so I hope that makes sense. And this is what gets preserved, and we call these cross beds. The reason why we call them cross beds is because, again, I can't see the whole ripple, so in order to tell which way that the current is moving, I need to make an X. I need to go across them. Okay, so if we take a look right here at this picture, right, you can see here's the nice big ripple mark, and you can see all those nice cross beds in there. This is what it looks like in real life. So you can, it's very obvious, very easy to see these nice, big, beautiful cross beds. So again, that tells me that my water is moving in this direction, right? Because it's going to cross over them. What I want to bring your attention to on this picture, though, you have these really high-angle cross beds, then you have these nice low-angle cross beds. That's telling you about the velocity of the water, right, that made those cross beds. So what's really great, again, about this is I can model the river system that might have been here millions of years ago, right, just by looking at the cross beds. We can also get these things called turbidity currents, which is something that we've talked about when we looked at plate tectonics, especially plate margins. So remember, out at your plate margin, right, you've got your continental shelf, your slope, and your rise. So right here at your shelf, what happens is this material, the water there becomes very heavy with sediment, as all that sediment is being carried out, and it'll roll down, literally roll down the hill and get deposited right at the base. As it's getting deposited, initially, because it's moving fast, only the big grains are going to get deposited first, right, which is what you can see here. As the current starts to slow down, the particle sizes get smaller and smaller. So that's why we call it a graded bed. Large particles on the bottom, small particles on the top. Now, on top of the sediment, we can also sometimes see some pretty cool features. We can get mud cracks. Mud cracks can easily preserve in the rock record. Mud cracks tell me that this is an area that was flooded and then dried out really, really fast. So again, telling me something about the environment. I can see scour marks, which is what we get here. So let's say, again, here we are at the bottom of a river, and in the river we've got a stick that's going to drag. Well, that stick is going to first poke into the sand, and then it's going to get dragged across the bottom. So it's going to leave a little indentation, right, along the bottom of the water. So that scour mark tells me, right, how it formed. Plus, it'll also tell me current direction, right, as it's pulling that stick along. Plus, of course, we can also see fossils, which, in my opinion, are the best part of the whole story. But this is evidence of all past life, right? So we can see footprints, we can see shells, we can see skeletons, we see all sorts of really great stuff. But they definitely tell us a lot about the environment.